Hello there, and welcome to the Sleepumentary channel. Tonight, as you settle into the quiet of your room, we're going to take a journey that gently reshapes the way you see the universe and the way you see yourself. You've heard about the Milky Way thousands of times, but very few people truly understand how vast it is or where it sits within the larger cosmos. The strange thing is this: the Milky Way is one of the largest galaxies humanity knows. Yet when you zoom out far enough, it becomes so small it almost dissolves into the endless dark. Tonight we're going to explore that true scale slowly, calmly, at a pace that lets the worries of your day loosen their grip. We'll travel from the quiet suburban corner where our sun resides past billions of stars through star clusters, galaxy groups, massive superclusters, all the way to the gigantic cosmic walls that stretch across billions of light years. And along this journey you'll discover something gentle but deeply meaningful. When you understand just how small we are in the universe, every pressure in life suddenly feels a little lighter. So lie down, breathe slowly. Your voyage across the Milky Way begins right now. So before we continue, hit like and subscribe so you don't miss a single revelation as this story unfolds moment by moment in real time. Tell me in the comments where you're watching from, what time it is there, and whether you believe we're hearing the whole truth about what's unfolding above our heads. And if you want to keep the signal alive, share this video on X, Facebook, Reddit, or even just with the people who still look up at night. You are the reason we can keep following the impossible, and for that, thank you. The journey that changes how we see the universe. Tonight, as you lie down, letting your breath settle, letting your eyelids grow heavier after a long day, we're going to step into a slow, deeply stirring journey. A journey that asks nothing of you, no effort, no memorizing, only that you listen and let your mind drift like mist carried by a quiet breeze. This journey begins right where your eyes land every night, a delicate band of light stretching across the sky. Ancient people called it the white road, the silver ribbon of night. Today we call it something familiar, the Milky Way, but tonight we won't look at it through human eyes. We'll look at it through the eyes of the universe to see the true scale of the galaxy we live in. And here is the beautiful thing. When we truly understand the size of the Milky Way, we don't just change the way we see the sky, we change the way we see our own lives. Imagine you're standing on an enormous harbour. Far away, the ship's lights line up into a glittering path, straight and endless, like a road stretching into infinity. From a distance, the ship seems tiny, but as you approach, you realize just how massive, towering, and unimaginable it really is. The Milky Way is the same. It spans 100,000 light years, meaning if a single beam of light began traveling from one edge to the other, it would have to move non-stop without resting for 100,000 years. And light is the fastest thing in the universe we know. We can express that number mathematically, but to truly feel it, that is something else entirely. And here comes our first paradox of the night: the Milky Way is a giant. But when you zoom out far enough, it becomes almost nothing at all. Just as Carl Sagan said in Cosmos, the cosmos is all that is, or ever was, or ever will be. And within that immense all that is, the Milky Way is nothing more than a speck of dust. Yet within that dust, in the quiet suburban corner where the sun lives, there is you lying there listening, existing, with all the complex and beautiful emotions of a human being. Tonight I want to invite you to visit a place most of us have never truly paused to observe: the Milky Way's real position within the structure of the universe. We'll begin at our tiny home, the solar system, where this blue planet orbits an ordinary star. From there we'll drift outward, passing clouds of dust sweeping past spiral arms, where hundreds of billions of stars burn quietly with their own colours and speeds. We'll reach the edge of our galaxy, then cross the intergalactic void to enter the local group, where the Milky Way is just one city in a region far larger than we can imagine. From the local group, we'll travel farther still to the Virgo cluster, then the Laniakea supercluster, and finally to the cosmic wall structures that stretch billions of light years across, so vast that even light needs billions of years just to skim a corner of them. And when we look down from that height, a height no other species has ever reached, we'll see that the Milky Way is not the center of the universe. It isn't special. It's simply a village in an endless cosmic ocean. But accepting that is where peace begins. When we understand our smallness, we don't feel insignificant. Instead, we begin to sense the fragile beauty of simply being alive. We start to understand that the pressures, worries, and burdens we carry are only gentle ripples across the vast lake of space and time. When you hear numbers like 100,000 light years, 2 trillion galaxies, or 93 billion light-years of observable universe, you might feel overwhelmed. That is completely normal. None of us were born to instantly comprehend scales like these. But because we cannot fully grasp them, we can enjoy them the way we enjoy a wordless symphony, wide, deep, and quiet. That's why you're listening to this program, not to memorize every detail, but to open yourself to the feeling of being part of something far larger than yourself, a feeling both humbling and empowering. And if during this journey you find your perspective shifting, if the night sky starts to feel different, if that faint glowing band is no longer just a streak of light, but an entire galaxy unfurling its spiral arms, then that is exactly our goal for tonight. Maybe after this, every time you look up at the sky, you'll remember that you're looking at a piece of your cosmic home sweeping across space. A home where every star you see is racing around the galactic center, like giant fireflies in the night of the universe. You will never look at the Milky Way the same way again. And before we begin this journey, I want to gently invite you, if content like this helps you relax, helps you sleep, or simply helps you feel less small in this life, you can take a moment to like or subscribe. No pressure, no dramatic music, no intense call to action, just a soft invitation light as a breath. If you choose to support it, becomes the energy that allows us to continue creating journeys like tonight's. Now, let your body sink deeper into the bed. Let your shoulders loosen. Your heartbeat settle into something slow and warm. Let the last thoughts of the day drift past like thin clouds. And when you're ready, we'll begin. The journey to discover the true scale of the Milky Way and its place in the universe starts here right now. Just listen. The universe will tell the rest of the story. Portrait of the Milky Way, a giant among galaxies. When you close your eyes, you might imagine yourself floating in space, looking down at the galaxy we call home, the Milky Way. To human eyes, it appears only as a faint, delicate band of light stretched across the night sky, so fragile you might think a single breath could blow it away into darkness. But in truth, hidden behind that thin, silky streak is one of the largest structures the human eye has ever witnessed, even if only indirectly through ancient light. The Milky Way is a barred spiral galaxy, with a bright star bar cutting across its core, from which 4 main spiral arms extend outward, like limbs slowly unfurling through space. Its diameter is roughly 100,000 light-years. That means if you stood at one end of the galaxy and turned on a flashlight aimed toward the other side, the beam, the fastest moving thing known in the universe, would still need 100,000 years to reach its destination. Take a moment with that. A light year is not time, but distance. The distance light travels in 1 year. Light moves at 186,000 miles per second, or about 300,000 kilometers. It can circle Earth 7 times in a single second. But to cross the Milky Way, it would have to travel from long before human civilization existed across thousands of generations all the way to today and still not arrive. When you understand this, the Milky Way no longer feels like a small band of light. It becomes something majestic, immense, a structure so vast that your imagination dissolves into specks of brightness the moment it tries to touch it. But size is not the only thing that makes the Milky Way extraordinary. Inside it lies a city of stars so crowded it's almost impossible to conceive. Astronomers estimate our galaxy contains 100 to 400 billion stars each, possibly with its own planetary system. And if even a tiny fraction of those stars have planets within the habitable zone, then the number of Earth-like worlds could reach into the millions. Imagine standing inside a colossal forest where the trees grow so densely that you can only see a few meters before everything disappears into woven shadows. If someone asked you how many trees are in this forest, you might laugh at the impossibility of such a task. And that is exactly what we face when trying to count the stars in our own galaxy. The Milky Way is an endless forest, each star each tree with its own story, its own environment, its own planets. And where we stand is only a single stump somewhere deep inside that forest. But here's something most people don't know. 95% of the galaxies in the universe are smaller than the Milky Way. This might sound backwards. We often think Earth is ordinary, the Sun is ordinary, and our galaxy is ordinary too. But the truth is different. If we placed every observed galaxy on a giant scale, the Milky Way would be in the top 5% among the largest. Most galaxies out there are dwarf galaxies, small, dim, containing only a few million to a few billion stars, lacking the graceful spiral arms or complex structure of ours. In other words, within the family of galaxies, the Milky Way is anything but small. It is an empire, massive, powerful, and intricate, with so much mass that it requires dark matter to hold all of its stars together. Without dark matter, the spiral arms of the Milky Way would be torn apart by their own rotation. The Milky Way is a galaxy that the universe must bind with invisible forces just to keep it whole. And yet here lies the paradox: when we leave the galactic scale and zoom out to the cosmic level, the Milky Way becomes unbelievably small. It's like looking at a huge city from an airplane. On the ground, each building can rise hundreds of feet. Each road feels wide and endless. But from 30,000 feet up, everything becomes thin lines and tiny glowing squares pressed tightly together. Our galaxy is the same. In the space between galaxies, the Milky Way is only a small dot, a grain of dust sitting on a tiny branch of the local group. And as we go farther to the Virgo supercluster, then Laniakea, then the universe's largest structures, it nearly disappears into the grand picture. As Carl Sagan once said in A Pale Blue Dot, we are like butterflies who flutter for a day and think it is forever. This fragility doesn't sadden us. Instead, it helps us appreciate the miracle of simply existing inside this enormous galaxy, gazing at starlight that has travelled thousands or millions of years just to reach the human eye. And so as you let your body relax in the darkness of your room and listen to these words, you are in truth lying on a small planet, orbiting an ordinary star drifting within a colossal galaxy, slowly rotating through space. A galaxy containing hundreds of billions of stories, hundreds of billions of worlds, and perhaps billions of possibilities for life. The Milky Way is a giant when you look closely, but only a speck when you look from afar. And that contrast is what makes it breathtakingly beautiful. And to truly understand our place within this giant, we need to know precisely where the sun sits among this sea of stars, a journey that begins in the quiet suburban outskirts of the Milky Way. The sun's position, the quiet suburbs of the galaxy. If you imagine the Milky Way as a vast city slowly rotating in the endless darkness of the universe, then the sun, the star that nurtures every form of life on our blue planet, is not located in its bustling downtown. It sits in the suburbs, a quiet, humble position far from the noisy districts where stars crowd together in hundreds of layers of light. Our sun is about 26,000 light-years from the galactic center, resting on a small spiral arm called the Orion Spur, or the local arm. It's not one of the grand sweeping arms that stretch tens of thousands of light-years across. Instead, the Orion Spur is like a side street tucked between two of the galaxy's major boulevards, the Perseus arm on one side and the Sagittarius arm on the other. It is the gentle corner of the universe where we were placed by chance, and that chance placement created the entire story of life. The region around the Orion Spur is a cosmic suburb, a place where stars are more sparsely spaced, where supernova explosions are less frequent, and where the density of high-energy radiation is much lower. If the sun were located deeper inside the crowded spiral arms where young stars erupt, where gas and dust collide violently, Earth might never have had the stable environment it needed for billions of years of life to emerge. Life to exist needs a pause, a long stretch of quiet unbroken by catastrophic events. The Orion Spur gave us that gift. If you've ever lived in a large city, you know the feeling of stepping onto a suburban street at night, the lights softer, the sounds gentler, the air lighter and more open. It's the perfect place to live, to raise children, to build a family quiet enough to be safe, close enough to the center to stay connected. The sun has found, or has been placed in such a place within the galaxy. When you look up at the night sky, every star you see with your naked eye, bright or faint white, yellow or blue, all of them belong to our own galaxy. No star from another galaxy is visible to the unaided human eye. Not a single beam from Andromeda, not one lonely star from nearby dwarf galaxies is bright enough to reach your vision. This may feel surprising, knowing the universe holds trillions of galaxies, but our eyes only reach our closest neighborhood, the stars of the Milky Way. Which means, from the moment humans appeared from our ancestors' firelit nights to the glow of modern cities, we have lived our entire history with only one vantage point, the viewpoint of beings living inside a galaxy. The sages of the ancient world looked up at the sky and believed they were seeing the whole universe. Those long, luminous streaks they thought were roads for the gods were actually just the edge-on view of our own galactic disk. Carl Sagan once wrote in Cosmos, "We live in a universe of unimaginable size, and yet we have lived through history believing our little corner was everything. We have been inside the Milky Way since long before humans even knew how to name it." Imagine standing in an open field looking at a city from miles away, All you see are dim lights on the horizon. You don't see the narrow streets, the bridges, the skyscrapers, you only see the glow, and you think that glow is the city. But in truth, you're only seeing the surface of a world far larger than your eyes can perceive. Every star in the night sky is like a distant lamp. Behind each one lies a planetary system that might have mountains, oceans, atmospheres, light, shadow, and perhaps beings who are wondering if someone is looking back at them. But the human eye sees only the light, not the world behind it. We have lived inside this galaxy for millions of years without ever truly seeing it from the outside. Before humans invented telescopes, we lived like people locked in a giant room with only a small window. We believed that window was the entire world. The Sun, a yellow G2V star, travels around the center of the Milky Way at 828,000 km/h. But you never feel that motion. You never sense that with every passing second the solar system lifts, carries you, and pushes you farther along its immense spiral path. All of its movement is as gentle as a silk carpet sliding beneath your feet. We are on a planet orbiting a star. That star is orbiting a galaxy. And that galaxy is drifting through intergalactic space, pulled by the gravity of hundreds of neighboring galaxies. Everything is moving, and yet we feel calm. Perhaps it is because the Sun's home, the quiet suburbs of the galaxy, allows that calm to exist. And in this moment, as you loosen your shoulders, as your breath slows, you are living on a tiny planet, placed in just the right pocket of quiet for life to begin, continue and grow into something capable of asking questions about the very universe that contains it. An ordinary star in an ordinary corner of an enormous galaxy, yet it gave rise to a species that asked, where are we in all of this? Stephen Hawking once said, we are just a chemical scum on a moderate-sized planet orbiting around a very average star. It sounds self-deprecating, but it reveals a paradoxical beauty. The Sun's ordinariness, the Orion Spur's serenity, created something extraordinary life that contemplates itself. And to understand our place within the Milky Way more clearly, we will need to step outside our small home and look toward our neighborhood, where our cosmic neighbors drift quietly through the darkness, forming a far larger picture. Our neighbors, Andromeda and the Magellanic Clouds. If the Milky Way is a vast city turning slowly in the darkness of the universe, then when we look beyond its spiral streets, we find a network of other cities shimmering in the deep void. And just like any city, the Milky Way does not exist alone. It has neighbors, some close, some distant each, with its own appearance, its own history, its own destiny. Among all those neighbors, the most prominent is Andromeda. Andromeda, or M31, is the largest galaxy in our local galactic neighborhood, even larger than the Milky Way. If the Milky Way contains around 100 to 400 billion stars, Andromeda contains nearly 1 trillion. A number so immense that if you spent a microsecond looking at each star, you would need more than 30 years without sleep, without breaks, just to glance at them all. And that would still only be a small fraction of the galaxy. The distance between us and Andromeda is 2.5 million light-years. That means the light leaving Andromeda began its journey when humans did not exist in any form. Long before painted cave walls, long before language, long before stories. When the light you see from Andromeda tonight first started travelling Earth, was wild and primates had not yet diverged from their ancient branches. And yet, despite the distance, Andromeda is not standing still. It is moving, always moving toward the Milky Way. Two giant galaxies are on a slow, gravitational collision course that will take billions of years. Roughly 4.5 billion years from now, the Milky Way and Andromeda will collide, pass through each other, and eventually merge into a new, larger, rounder galaxy, perhaps called Milkdromeda. Still, there is nothing to fear. A galactic collision is not a collision of solid objects like two crashing spheres. The distances between stars are so vast that when two galaxies sweep through one another, the chance of two stars actually hitting each other is nearly zero. Instead, gravity will stretch their spiral arms, distort orbits, and after billions of years, everything will settle into a single quieter galaxy. No explosions, no catastrophic crashes, only very slow, very soft shifts like a cosmic tide rolling through the centuries. But Andromeda is not the Milky Way's only neighbour. If you have ever visited the southern hemisphere, you may have seen two pale, glowing smudges hanging in the sky. They are not clouds, and they are not dust. They are the Large Magellanic Cloud LMC and the Small Magellanic Cloud SMC, two satellite galaxies of the Milky Way. These Magellanic Clouds are dwarf galaxies. much smaller than the Milky Way yet profoundly important. They are not just neighbours, they are younger siblings still held within the Milky Way's gravitational orbit. The LMC contains around 10 to 20 billion stars, while the SMC contains several billion. At that scale, they lie fully within the Milky Way's gravitational influence. Streams of gas stretch between them and the Milky Way, the Magellanic Stream, proof of an ancient gravitational relationship linking these three galaxies. From the southern hemisphere, the LMC and SMC are visible to the naked eye, not as distinct bright stars, but as gentle luminous patches drifting on the night sky, so beautiful that when Ferdinand Magellan and his crew first saw them, they thought they were looking at pieces of the Milky Way itself. And in a sense, they were right. These dwarf galaxies are small fragments slowly being pulled into the Milky Way's embrace. The presence of Andromeda, LMC and SMC gives us a tender truth: the Milky Way is not alone. We live in a galaxy with companions, with friendly neighbours, with an entire small family called the local group. In that family, the Milky Way is like an older sibling, not the biggest. That title belongs to Andromeda, but certainly strong, influential, and surrounded by younger members. Perhaps that offers us a strange kind of warmth. In an immense, cold, dark universe, the Milky Way still exists within an organised structure, a place with closeness, with gravity-sculpted relationships, billions of years old. We are not wanderers drifting alone through a sea of stars. We are residents of a cosmic neighbourhood. If you lie down and imagine the night sky as a giant dome, every star a glowing house, then Andromeda is like the light of a distant city, close enough to see, far enough to remain mysterious. The two Magellanic Clouds are like gentle lanterns from small villages softly drifting along the horizon. The universe may be unimaginably vast, but in its own way it feels like the neighbourhood where you live. Big houses, small houses, crowded families, faint porch lights, and neighbours you can see every night if you simply look up. What makes all of this even more beautiful is that we always see these neighbours from inside the Milky Way, never from outside. We are like people living in a tall building who can see only one side of the street, yet we try our best to imagine the entire neighbourhood. This is what makes astronomy a journey of imagination and humility, and it is what makes every discovery feel miraculous. And if these neighbours are just the beginning of the picture, then to truly understand where the Milky Way belongs, we must look farther still toward the local group, the cosmic neighbourhood in which the Milky Way is only one of its major cities. Local group, the Milky Way's cosmic neighbourhood. When we step away from the Milky Way and the satellite galaxies around it, our view expands to a higher level. If the Milky Way is a grand city drifting through cosmic darkness, then surrounding it are not just a few isolated neighbours, but an entire cosmic neighbourhood. A place where galaxies move around one another in gravitational spirals that last billions of years. That place is called the local group. Imagine you are flying through the universe far enough from the Milky Way that it becomes nothing more than a thin glowing disk swirling gently in space. Then you drift even farther back and suddenly you see it isn't alone. Beside it is Andromeda, powerful and radiant like a sibling city. And around those two cities, countless smaller lights shimmer, dwarf galaxies drifting along shared gravitational paths. The local group is a collection of roughly 50 galaxies spread across a vast region, about 10 million light-years in diameter. The Milky Way and Andromeda are the two largest members, like two enormous metropolitan centres sharing the same night sky. They contain most of the mass in the group, and the smaller galaxies around them are like towns and villages orbiting these two galactic hubs. One of the most important galaxies after the Milky Way and Andromeda is the Triangulum galaxy, or M33. Triangulum is smaller but still a genuine spiral galaxy, with slender bright arms forming a graceful orderly structure. It is like the energetic youngest sibling of the family, small but full of vitality. Triangulum contains about 40 billion stars, not many compared to Andromeda, but enough to make it a complete, balanced and beautiful galaxy. And fascinatingly, Triangulum is not only a member of the local group, but also has a special gravitational connection to Andromeda, like two glowing lanterns circling each other in the darkness. Seen from far away, these three spiral galaxies, Andromeda, the Milky Way and Triangulum, appear as the brightest cities in the region. Around them hover dozens of dwarf galaxies so tiny that compared to the Milky Way they are like quiet little villages on the outskirts of the cosmic neighbourhood. These dwarf galaxies, Leo's Draco, Ursa, Minor Sculptor, Phonax, each hold their own story. They are modest worlds with a few 100 million or a few billion stars. Their light is so faint we can only see them through telescopes. yet they drift silently along the gravitational river of the local group, following paths drawn by the powerful gravitational fields of the two main galaxies. At this scale, the local group resembles a small but well-organized community. Every galaxy in the group is tied together by shared gravity. None can simply wander away the massive pull of the Milky Way, and Andromeda keeps them all involved in a delicate rotating dance. If you imagine a nighttime map of Earth, seen from space, major cities glowing brightly, small towns flickering in scattered clusters, the local group has a similar structure. The Milky Way and Andromeda are the New York and Tokyo of this region. Triangulum is like a mid-sized city Barcelona, Vancouver or Melbourne. And the dwarf galaxies are like quiet rural towns sparsely populated, yet still part of the shared network. What makes the local group fascinating is its cohesion. In the universe, most galaxies do not travel alone. They cluster into groups, and those groups form even larger clusters. The local group is the level to which our galaxy belongs, not as crowded as the Virgo cluster, but not isolated either. This just right balance, spacious yet peaceful, makes the local group an ideal place for spiral galaxies, like the Milky Way, to evolve naturally, avoiding early destructive collisions or harsh radiation fields that might tear them apart. In a sense, the local group is like a beautiful neighborhood, not too loud, not too crowded, and not stranded in a lonely open field. It is a place where galaxies can live out their billion-year lifetimes, changing shape, evolving, merging then drifting once more in the slow rhythm of the cosmos. And just like humans, each galaxy in the local group has its own position, story and pace. Some dwarf galaxies have been torn apart from passing too close to the Milky Way. Some are racing toward Andromeda. Some appear almost motionless from our vantage point. And all are small parts of a system larger than themselves, a network we're only beginning to understand. Carl Sagan once wrote, "The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. This is true not only for living creatures, but for the galaxies of the local group. Their beauty lies not in the number of their stars, but in how they orbit, interact and influence one another in a stable structure that has existed for over 10 billion years. What makes the local group special is that it shows us the Milky Way's place within something larger. We don't belong only to the Milky Way, we belong to a community of galaxies. We are citizens of a cosmic neighborhood where every light, big or small, contributes to the shared picture. As you lie down and close your eyes, imagine the Milky Way as a glowing city slowly spiraling in the dark. Then imagine other lights, Andromeda Triangulum, and dozens of dwarf galaxies drifting around it like small boats on a nighttime sea. That is the local group, a vast expanse yet familiar enough to be considered our neighborhood in the universe. But the local group is only a tiny grain in a far larger structure. When we leave our neighborhood and look farther, we find that the Milky Way is just a single bright spot within another colossal framework, the Virgo supercluster, the larger home in which we are all drifting. Virgo supercluster. When an entire galaxy group becomes a single tiny dot. When we leave the local group, our cosmic neighborhood, and travel farther outward, an entirely new doorway opens before us. Everything becomes so large that our imagination must contract just to keep up. Galaxies we once considered enormous suddenly look like thin, fragile grains of glowing dust. The entire local group with its dozens of galaxies shrinks into a modest speck within a far grander picture. We have entered the Virgo supercluster, a cosmic structure so vast that compared to it the Milky Way is just a room inside a house, and the entire local group nothing more than a small stone lying in a corner of the yard. The Virgo supercluster is unlike anything we've encountered before. It is a collection of at least 100 galaxy groups and clusters stretching across roughly 110 million light-years of space. For comparison, the Milky Way is 100,000 light-years wide, meaning the Virgo supercluster is over 100 times larger than our galaxy. If you imagine a nighttime map of Earth stretched 100 times, its size, cities, towns and villages would all dissolve into a network so massive your eyes could no longer recognize any familiar shape. The Virgo supercluster is exactly like that region of space where quintillions of stars reside, woven into a pale blanket of light fading into the cosmic darkness. At the center of this supercluster lies the Virgo cluster, a cosmic metropolis of 1,000 to 2,000 galaxies gathered in one place. Among them, the giant elliptical galaxy M87 stands out, housing one of the largest known supermassive black holes. The image of M87's black hole released in 2019 a hazy red-orange ring encircling a perfect lightless shadow, is proof of gravitational forces that stretch far beyond our imagination. When you look at that image, you're looking at the heart of a colossal galaxy inside a colossal cluster, within an even more colossal supercluster. The Virgo supercluster does not have a clear shape like the Milky Way or Andromeda. It resembles a luminous web of threads with clusters such as Virgo, Coma Leo, and Hydra, connected by filaments, enormous corridors of gas and dark matter. In cosmic simulations, the Virgo supercluster looks like a glowing forest of mushrooms, bright domes marking galaxy clusters, and thin glowing stems representing the filaments between them. Between those filaments lie vast cosmic voids, empty regions so large that light requires tens of millions of years just to cross them. Within this picture, our local group with its 50 galaxies, and the Milky Way and Andromeda as its elders, is merely a small room at the edge of an impossibly large building. If the supercluster shifts, the entire local group trembles slightly. If the Virgo cluster rotates nearby, galaxies subtly adjust their speeds. All of it is governed by something we cannot see, dark matter, which exists in quantities 5 times greater than normal matter and acts as the skeleton of the entire cosmic superstructure. These movements unfold in absolute silence. No sound, no shaking, no bursts of light, only gentle, imperceptible motions that a human being could never sense in a lifetime. Stephen Hawking once said, "To understand the universe, you must think in terms of time far beyond the scale of human life. Nowhere is this more true than in the Virgo supercluster, where time is measured in hundreds of millions of years. Imagine standing on the outskirts of a city. From far away, you see tall buildings, highways, and streams of dim light stretching to infinity. But as you move closer, you realize each of those buildings contains lives, stories, and histories of its own. A supercluster is like that. Each galaxy holds trillions of potential stories, each story resting inside a world we have never stepped foot on. If the Virgo supercluster is a massive city, then the Milky Way is merely a room in a small house. Andromeda is the second room, triangulum, a tiny nook on the lower floor. The dwarf galaxies scattered around are like posters tacked onto the walls. Yet in that single room, the Milky Way, we appeared. A species curious enough to ask about the universe, to look up at the sky and wonder, is there anyone else out there? What makes the Virgo supercluster beautiful is not only its size, but the delicate order of its structure. Galaxies are not strewn randomly. They form patterns, clusters, groups, filaments, voids, as if the universe were weaving an enormous tapestry of light. This tapestry stretches hundreds of millions of light years, and each glowing point upon it is a world of its own, rotating quietly in the cosmic night. As you let your body relax and your breathing slow, imagine yourself drifting across that tapestry, gently like a leaf floating down a river. You do not need to understand everything at once. All you need to know is that you lie within a structure far larger than yourself, and that this structure itself belongs to something even larger still. As Carl Sagan wrote in Cosmos, we find that we live on an insignificant planet of a humdrum star lost in a galaxy, tucked away in some forgotten corner of a universe. And strangely, it is this very insignificance that makes everything feel beautiful and meaningful. But even the Virgo supercluster is only a small district on the map of the universe. When we zoom out farther, we discover that this supercluster is just one delicate petal in an even grander structure, Laniakea, our true cosmic homeland. And just like that, when we leave our neighborhood and look farther, we see that the Milky Way is only a bright dot in this immense superstructure. The Virgo supercluster, the vast home through which we all drift. Laniakea, the boundless heaven and the great attractor. When we leave the Virgo supercluster already far beyond anything human imagination was designed to grasp, we step into a region of space even larger. A realm light as a breath, yet so vast that ordinary language fails to contain it. Scientists gave it a name that is both gentle and sacred, Laniakea Hawaiian for immeasurable heaven or boundless paradise. Laniakea is the supercluster of superclusters, a cosmic continent roughly 520 million light-years across, containing around 100,000 galaxies. If the Milky Way is a dust grain inside the local group, and the local group is a tiny house inside the Virgo supercluster, then Laniakea is a continent, a sprawling land, where each galaxy is just a lonely little city hidden somewhere in an endless cosmic forest. When you look at Laniakea on a 3D cosmic map, it resembles a giant flower, its petals made of filaments filled with galaxies radiating outward in different directions. Those filaments flow into one another, merging, curving, bending like water, cascading down a mountainside. And within that majestic structure, our Milky Way is just a faint point of light drifting in the current alongside tens of thousands of other galaxies. The wonder is this: we are moving. Everything is moving. Not moving randomly, but following the flow of a gravitational river. And that river leads to a mysterious, shadowed, indescribably strange region, scientists named with poetic intuition the Great Attractor. The Great Attractor is not an object like a star or a black hole. It is a region of space with an extraordinarily high mass density, generating a gravitational pull so immense that all of Laniakea, tens of thousands of galaxies, is drifting toward it, the Milky Way included. Everything we know, you, me, the sun, the planets, every memory and story is moving toward the Great Attractor at 600 km. Every second, our entire galaxy races forward at twice the speed of a bullet, and yet you and I feel nothing. No vibration, no wind, no force tugging us forward. Space has no wind, no friction, no anchor. We simply drift, softly like a leaf sliding across the surface of a silent lake. Imagine the Milky Way as a small boat. The local group is the water around it. The Virgo supercluster is a wide stretch of river, but Laniakea is the entire ocean. And within that ocean, the Great Attractor is like a massive whirlpool, but not destructive. A gentle pull guiding everything inward with a force both invisible and beautifully mysterious. It feels like standing on a quiet morning beach. The ocean seems still, yet the tide is silently shifting beneath the surface, slow, smooth, without a single warning sound. Laniakea behaves just like that. We're not still. We're drifting through a gravitational current so vast that even light needs hundreds of millions of years to cross it. The Great Attractor lies in the direction of the constellation Norma, but our view of it is blocked by dense lanes of dust inside the Milky Way. That is why we cannot see it, even though it is influencing hundreds of thousands of galaxies. Scientists once described the sensation of tracking the Great Attractor like this: it is like feeling a tide you cannot see. As if you sense the current pulling you, even while the water's surface remains flat and still. The universe is not only huge, it is filled with currents we are only beginning to notice. Space is not static, it is a river, and we are floating within it. Now imagine yourself lying down, eyes closed. Your breath slows, your body lightens. You too are drifting not just in the air of your room, but in a cosmic expanse so vast it escapes every framework of ordinary thought. The Milky Way, a tiny leaf in that cosmic river, is gently being carried toward the Great Attractor. And the Great Attractor is not still. Either it is part of an even larger current flowing into deeper cosmic structures where light needs billions of years to travel. Thinking about this might make you feel small, but it may also make you feel connected, as if you were resting on the surface of a great ocean, sensing its rhythm. Carl Sagan once said in Cosmos, "We are a way for the universe to know itself. We do not simply drift through the universe. We observe it, reflect on it, and through that reflection the universe becomes aware of its own existence." Laniakea, with its 520 million light-years of reach, its 100,000 softly spinning galaxies, its Great Attractor beating like an invisible heart, teaches us that our place is far from insignificant. We are embedded within a cosmic flow so immense that everyday human worries become airy as mist, and strangely that brings peace. But as vast as Laniakea is, it is still only one fragment of the cosmic map. When we zoom out even farther, superclusters begin to connect into an even larger network, the cosmic web, the largest structure humanity has ever seen. The cosmic web walls, filaments and voids. When we leave Laniakea, the boundless heaven of galaxies, and extend our view even farther, a strange new picture begins to appear. This is no longer the realm of individual superclusters or isolated gravitational flows. This is the grand pattern, the largest structure humanity has ever mapped the cosmic web. And from the very first glance you notice something almost unbelievable. The universe is not evenly filled with galaxies. Galaxies do not float through space like dust in the air. They do not scatter randomly across the void. Instead, the entire universe is woven together by colossal threads of light. Galaxy filaments stretching hundreds of millions of light years, connecting into a three-dimensional network that spans billions of light years. Between those threads lie regions that are almost completely empty, the void so vast that light needs billions of years to cross them. This structure is so beautiful it feels surreal. It resembles a gigantic sponge where galaxies cluster along the walls of each bubble, while the interior space is nearly hollow. Let's begin with the threads, the filaments. These are enormous rivers of galaxies stretching along graceful curves like glowing streams. They form highways of high galaxy density, great boulevards cutting through the cosmic darkness. Along these filaments, galaxies do not simply stand still. They drift, rotate, fall into one another, merge and grow. Filaments are where the universe gathers matter and reorganizes itself. Here gravity behaves like flowing water, drawing in gas, dust and stars and swirling them into new galaxy clusters. From afar in simulations, the filaments look like the veins of an enormous organism or the roots of a great tree spreading underground, connecting everything into a single unified network. But filaments are not alone. Between them lie the galaxy wall structures so enormous they make entire superclusters look small. One of the first discovered walls was the CFA2 Great Wall, about 500 million light-years long. To visualize it, that structure is roughly 5,000 times the width of the Milky Way. Later, scientists discovered the Sloan Great Wall even larger, stretching across 1.37 billion light-years. That is a distance light needs more than 1 billion years to cross. 1 billion years meaning when light left the beginning of that wall, Earth had only single-celled organisms drifting in the oceans. There were no fish, no plants, no complex life at all. These walls are not solid barriers of rock or metal. They're collections of hundreds of thousands of galaxies, each holding billions or trillions of stars. They're grand avenues of light etched across cosmic darkness, arranged in delicate forms shaped by gravity over tens of billions of years. From afar, they look like the glowing edges of a bubble, bright along their walls, hollow in the center. And then we reach the voids regions so enormous they defy human standards entirely. One of the largest voids near the Milky Way is the KBC void, around 2 billion light-years wide. It is almost completely empty. No stars, no large galaxies, no dense gas. Only sparse particles of baryonic matter scattered as thinly as ash carried by the wind. Imagine looking at a sponge. The empty bubbles within it are the voids, and the surfaces between those bubbles are where galaxies gather the filaments and the walls. The universe resembles a hollow architecture made of light, a symphony of emptiness and density where darkness and luminosity weave together into the largest shape humans have ever recognized. In a discussion of cosmic structure, physicist Joe Dunkley once said, "The universe is not filled with galaxies. It is filled with voids decorated by galaxies around their edges. The universe is not full of stars, it's full of emptiness. Stars are merely the bright decorations along the edges of that emptiness." And what makes the cosmic web breathtaking is not only that it surpasses every human measure of size, but that it possesses a fluid artistic grace. Filaments like threads, walls like the surfaces of cosmic bubbles, voids like the universe's deep, quiet breaths. When you look at a map of the cosmic web, you see a beauty no painter has ever captured. It is the universe's own natural artwork painted with gravity, time-expanding space and supernova that died billions of years ago. And the greatest wonder of all is this. We Earth, the Sun, the Milky Way are just a speck on the edge of one of those countless filaments. As you close your eyes and breathe slowly, imagine yourself drifting along one of those threads, slowly, quietly. Around you are distant galaxies, each one a world of 1 trillion suns, yet the space between them is so vast that everything feels as peaceful as a windless afternoon. You're resting upon one of the universe's threads, a single strand in a network stretching billions of light-years across. And even the cosmic web is not the final frontier. Because when we extend our vision even farther far enough that even the cosmic web becomes a tiny pattern, we approach the deepest question of all: does the universe have a boundary that is our next journey? The observable universe, and why? It's 93 billion light-years across. When we look beyond, the cosmic web space begins to unfold like a curtain with no edge. Galaxy walls stretching billions of light-years shrink away, filaments become thin strands, and voids once vast like cosmic chasms fade into quiet gaps between an even larger network. This is when we reach a foundational concept in astronomy: the observable universe. A sphere of light surrounding us so wide that any number feels too small to describe it. The first thing that confuses many people is this: the universe is only 13.8 billion years old. So how can the observable universe be 93 billion light-years across? The answer lies in the expansion of space, cosmic expansion, the central rule of the Big Bang model. Imagine watching a small boat drifting across the ocean. It left the shore long ago, rowing steadily into the distance. The light from that boat behaves the same way it left its galaxy billions of years ago to try to reach us. But the ocean the boat is travelling across is not still. It is expanding, stretching, flowing outward. This means that while light is moving toward you, the space between you and the source is expanding, pulling the boat farther and farther away, stretching the distance the light must travel. That is why a galaxy whose light has been travelling for 13 billion years is now 32 billion light-years away in actual distance. And when we draw the full sphere of everything, whose light has had time to reach us since the Big Bang, we get a diameter of roughly 93 billion light-years, a size so large it leaves every human yardstick utterly meaningless. Notice this: when you look at a distant galaxy through a telescope, you are never seeing it right now. You're seeing its past light that left it long before Earth formed, long before the Sun had a name. Some galaxies we observe today emitted their light over 13 billion years ago, long before Earth, the Sun, the Milky Way, or any version of us existed in any form. And those galaxies themselves, they are now tens of billions of light-years away. We are only seeing their ghosts shimmering gently in the night. Carl Sagan once wrote in Cosmos, "We are looking back in time and seeing the universe as it was. Every time you look at the sky, you're watching history drift by." Within this 93 billion light-year sphere, scientists estimate 2 trillion galaxies, 200 sextillion stars, 200,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,and perhaps quadrillions of numbers so large they escape the grip of language. If the Milky Way contains 100-400 billion stars and counts as one of the larger galaxies, then in this cosmic ocean, it is nothing more than a single grain of sand on an infinite shoreline. When you hear these numbers, your first instinct might be to feel small, but that feeling doesn't have to be frightening. It can be freeing, as if the weight of daily pressure lifts, because the universe is not asking us to be perfect. Imagine this: the observable universe is like a glass sphere 93 billion light-years across. We tiny humans stand at its centre not because we literally are, but because light from all directions has had time to reach us. Any observer anywhere in the universe would see themselves at the centre of their observable sphere. No position is privileged, no galaxy is favoured, there is no middle of the universe. The Milky Way is just one of 2,000,000,000,000 galaxies. Not the largest, not the smallest, not the most important, not the most forgotten. Simply one ordinary galaxy doing its ordinary work in a space that doesn't obey human hierarchies. Stephen Hawking once said, "The universe doesn't owe us a meaning. We create meaning by being here to understand it." Perhaps that is the most beautiful truth of all. The universe doesn't assign us a role, we choose it ourselves. And when you lie down, close your eyes and know that there are 2 trillion galaxies out there, each with hundreds of billions of possible worlds, you may feel small, but you may also feel like you belong to a story far larger than anything humanity has ever dreamed. You're lying on a tiny planet orbiting an ordinary star sitting at the edge of a spiral galaxy, tucked inside a modest galaxy group within an unremarkable supercluster, resting on a thin filament of the cosmic web, and that entire structure is only one small piece of the observable universe. And the observable universe is still not the whole universe, because when we look beyond the distance light can reach beyond those 93 billion light-years, we step into the realm of things we cannot see, only infer. The realm of inflation darkness, and the biggest question of all: does the universe have an edge at all? The galactic garden from dwarfs, spirals to ellipticals, and the strange ones. As we cast our eyes across the 93 billion light-year expanse of the observable universe, we begin to see a strange garden, a galactic garden. Not a garden of grass or flowers, but a realm where trillions of galaxies rise like living organisms, each with its own shape, colour and personality. If you close your eyes, imagine yourself gliding through that garden at a kind of cosmic twilight spiral, structures glowing softly like blooming flowers, smooth elliptical masses drifting like pale clouds, and odd misshapen galaxies smeared across the dark like ink spreading across still water. In this galaxy zoo, astronomers often group galaxies into major families. Spiral galaxies, rotating disks with elegant spiral arms like our Milky Way containing tens of billions of stars. Elliptical galaxies, oval-shaped lacking spiral arms, filled with old stars and very little dust. Irregular galaxies, galaxies with no fixed structure stretched and distorted by gravity. Ring galaxies, rare, beautiful circles of stars suspended in space. Peculiar galaxies, hybrids and oddities born from collisions stretching, tearing, warping like scars cut through the fabric of space. Some galaxies are tiny and faint like clusters of distant fireflies. Others blaze brightly and spin wildly like storms of light. But in this enormous garden, our Milky Way is just an ordinary flower, not the biggest, not the smallest, simply balanced. And yet when we look closer somewhere in the universe, there are giants, galactic monsters so immense they make the Milky Way look like a child standing next to a titan. Let's begin with one of the largest galaxies ever observed, ICE 1. ICE 1 lies roughly 1 billion light-years from Earth. It is not a graceful spiral or a faint dwarf. ICE 1 is a supergiant elliptical galaxy spanning 4.6 million light-years across about 40 to 60 times the size of the Milky Way. If you placed ICE 1101 next to the Milky Way, our galaxy would appear as nothing more than a small speck on its rim. ICE 1101 may hold tens of trillions of stars, hundreds of times more than our own. It is so vast that if you placed the Milky Way inside it, our sun would not even reach a tiny fraction of its luminous dome. Another contender for the title of galactic monster is A2261 BCG. This galaxy is famous for its extraordinary core, a central region up to 10,000 light-years wide, larger than the entire diameter of many small galaxies. A2261 BCG may contain hundreds of trillions of stars sitting at the center of a massive galaxy cluster. It is believed to be the product of multiple colossal galaxy mergers over billions of years. When you look at A2261 BCG through a telescope, you don't see tidy spiral arms or a clean oval shape. You see a diffuse glow, featureless, heavy and dense, like a cloud of ancient light gathered from tens of billions of years of cosmic evolution. And then there is M87, one of the most famous elliptical galaxies located in the Virgo cluster. It is home to the first supermassive black hole ever imaged directly by humanity in 2019. That red-orange ring surrounding a perfect black shadow remains one of the most iconic images in human history. M87 contains roughly 1 trillion stars, but its defining feature is the supermassive black hole at its center, weighing 6.5 billion times the mass of the Sun. A bottomless pit so large that if placed at the center of the solar system, its event horizon would swallow every planet, including Neptune's orbit. When you look at the black hole of M87, you're looking at the boundary of physics where space and time bend so sharply that our familiar laws fall silent. But remember this, these colossal, extraordinary mind-bending galaxies like ICE 1101, A2261, BCG and M87 are extremely rare. They are like ancient redwoods in a forest, magnificent, towering, but only a tiny fraction of the whole. Most galaxies are dwarfs, small, dim, modest, containing only a few 100 million stars or even a few million. Many are so small that next to the Milky Way they would look like faint clouds drifting beside a mountain. The universe is a place where small things dominate and giants appear only occasionally as beautiful exceptions. In a lecture, astrophysicist Neil deGrasse Tyson once said, "Most of the universe is not made of grand dramatic objects. It is made of quiet things waiting in the dark. Galaxies are no different. Imagine drifting through this garden, passing by galaxies of all kinds. Some rotate slowly like lotus flowers opening in space. Some shine brightly like lanterns in the eternal night. Others appear as streaks of light stretched thin by ancient collisions. Each galaxy is a story, a history, a timeline billions of years long contained within a single speck of light. And this entire garden, trillions of galaxies, is still only a small part of the observable universe. To understand why these galaxies take different shapes, sizes and destinies, we must understand the engine behind it all from matter to energy. That is the story of dark matter and dark energy, where 95% of the universe exists in a realm our eyes can never see. Why the Milky Way is still considered a giant. After travelling through the vast galactic garden where cosmic giants like ICE 1101 or rise like colossal engines of light, it's easy to think that our Milky Way is simply an ordinary galaxy. perhaps even unremarkable. But the truth is very different. When you zoom out to the full cosmic picture, the Milky Way is still one of the universe's giants. Let's begin with a simple, gentle statistic. If you randomly select 1,000 galaxies in the universe, chances are about 950 of them are smaller than the Milky Way. This may surprise you. We tend to be dazzled by those titanic galaxies often mentioned in science documentaries, but those are just rare, beautiful exceptions like ancient redwood trees hidden in an endless forest. Most galaxies out there are dwarfs, containing only a few million to a few billion stars, only a few thousand light-years across, so faint that they can be difficult to detect in the cosmic dark. Many dwarf galaxies are so small that placed next to the Milky Way they would look like tiny smears of dust floating beside a mountain peak. Our Milky Way contains roughly 400 billion stars, spans about 100,000 light-years, and falls within the top 5% of the largest galaxies in the universe, both in size and mass. Which means, in the landscape of trillions of galaxies, the Milky Way belongs to the true empires. Imagine the universe as a political map stretching 93 billion light-years across. There are small nations, peaceful, beautiful, lightly populated, and then there are great empires with hundreds of billions of citizen stars and countless cities, planetary systems. If galaxies were countries, the Milky Way would not be a lonely island lost in the ocean. The Milky Way is a superpower, an empire with substantial influence within its region. In the local group, the Milky Way and Andromeda are the two dominant powers, like two major nations shaping the entire neighborhood. The dwarf galaxies around them are like smaller states drifting within the gravitational pull of these two giants. The strange thing is this: we often feel our galaxy is ordinary, simply because we compare it to a handful of enormous outliers, like IC1101. But if we look at the distribution of galaxy sizes across the universe, galaxies like IC1101 or A2261 BCG are extremely rare cosmic monsters formed only when massive galaxies collide and merge over tens of billions of years. By contrast, the Milky Way is stable, balanced, beautifully spiraled, rich in gas to form new stars, and has maintained its structure for billions of years. This makes it an ideal, mature galaxy, not too old, not too young, not shredded by violent collisions, and not exhausted like ancient elliptical giants. You can imagine the Milky Way as a large, healthy tree, steady flourishing, spreading its branches evenly over many centuries. It doesn't need to be the tallest to be one of the most beautiful. What makes the Milky Way impressive is not just the number of stars, but also its system of satellites, its spiral structure, its central bar, and its vast surrounding halo. The dwarf galaxy often lacks the gravity to hold its shape. It can be torn apart by outside forces, but the Milky Way is strong enough to hold dozens of dwarf satellite galaxies in stable orbits, maintain its spiral structure for billions of years, support an extended halo many times the disk's diameter. These are the traits of a superpower galaxy, not an average one. If you've ever seen a global wind map, you know that some atmospheric vortices remain strong and stable for long stretches of time. The Milky Way is one of those vortices, steady and resilient within the cosmic flow. In a classic astronomy lecture, Carl Sagan once said, "There is nothing special about our place in the universe." But what he meant was not that our galaxy or our location is unimportant. What he meant was, the universe does not play favorites. No location is chosen. Even if the Milky Way sits among the top 5% in size, that does not make it more meaningful than other galaxies. It is simply one variation among countless structures the universe has woven, just as a forest contains tall trees, short trees, strong ones, fragile ones, all contributing to the life of the forest. The universe does not rank things by value, only by scale, and by that measure, the Milky Way remains one of the gentle giants. When you close your eyes and picture our galaxy, imagine it as an island of light slowly rotating in the cosmic dark, a large island full of potential life, holding hundreds of billions of suns and hundreds of billions of possible stories unfolding across distant worlds. We live on a small planet inside a large galaxy, a place spacious enough to hold every dream humanity has ever had. If you could see the Milky Way from the outside, you would witness an elegant spiraling structure, soft, intricate, beautiful, like a giant cosmic flower spinning in the wind, and you would realize that even though it's not the largest, it is still one of the universe's great wonders. And to truly understand why the Milky Way is so strong and so stable, why it can hold hundreds of billions of stars in its embrace, we must step into the mysterious darkness that makes up 95% of the universe, the realm of dark matter and dark energy, how a galaxy forms the 13 billion year history of the Milky Way. As you lie still in the darkness of your room, it's hard to imagine that the galaxy we live in, the Milky Way, was not always as magnificent as it is now. It wasn't born as a vast spiral disk hundreds of thousands of light years wide, didn't begin with graceful arms full of stars, nor with a glowing bar of light at its center. The Milky Way we know today is the result of 13 billion years of formation, merging collisions and evolution, a history as long as the age of the universe itself since the Big Bang. When you look at the night sky, you're looking at the longest fairy tale ever written, the story of a galaxy that grew from the tiniest fragments of the early cosmos. In the first millions of years after the Big Bang, the universe held only hydrogen, helium, and darkness. No stars, no planets, no galaxies. But within that darkness, tiny pockets of dark matter called mini-halos began to form. They were like the first drops of dew gathering gas, cooling it, and allowing the first stars to ignite. These mini-halos were so small, they held only a few million stars compared to the Milky Way's 400 billion stars. Today, they were barely faint lanterns in the cosmic twilight. Yet those mini-halos were the foundation of everything. They were the seeds of galaxies, the very first kernels planted in the cosmic field. Scientists call this era the Cosmic Dawn. As hundreds of mini-halos drifted closer under gravity, they began to merge. Each merger wasn't an explosive crash like we might imagine, but more like great clouds drifting into one another, melting together, blending, forming larger and larger clouds. The Milky Way was built through hundreds of such mergers. Small galaxies dissolved into ours, donating their stars' gas orbits and countless subtle fragments of themselves. Today in the stellar halo, the vast shell of stars extending hundreds of thousands of light years around the Milky Way, we can still see the remains of galaxies swallowed long ago. These stellar streams, stretching like faint smoke across the sky, are the remnants of ancient civilizations of stars' galaxies that once had their own lives, their own light, before the Milky Way folded them into its embrace. Astronomers call the reconstruction of our galaxy's past from these remnants galactic archaeology. If archaeology on Earth uses bones, pottery stone, and sediment to piece together human history, then galactic archaeology uses starlight. Every star carries a chemical signature, its precise mix of elements like iron, carbon, oxygen, magnesium, and silicon. Each ratio is like a fingerprint. And the remarkable truth is different galaxies have different chemical fingerprints. So when astronomers find a cluster of stars in the halo with matching chemistry, but distinctly different from native Milky Way stars, they know those stars originated in another galaxy, one that was merged into the Milky Way billions of years ago. It's like finding a lone piece of pottery buried in ancient soil. You know it came from another culture. The Milky Way holds many such pottery pieces. One major merger has become famous, Gaia Enceladus. It was a medium-sized galaxy devoured by the Milky Way around 10 billion years ago. Its aftermath is still visible today. A huge population of stars in the Milky Way's halo bears Enceladus's chemical signature, and their orbits spin backward like leaves drifting against the wind. Another ongoing merger is the Sagittarius dwarf galaxy, which is still being torn apart as it orbits the Milky Way, leaving behind long, delicate rivers of stars stretching across the sky like cosmic silk. By studying these remnants, we can read the Milky Way's history through its light, as if reading the diary of a mature galaxy. The most important truth of all is this: the Milky Way was never a single solid structure formed after the Big Bang. It is the product of countless mergers, long ages of growth, and the accumulation of information over billions of years. It is a living entity in the most beautiful astronomical sense. It was born from the smallest fragments. It grew through the resonance of hundreds of galaxies. And it continues to evolve as time expands. When you see that faint band of light across the night sky, remember you're looking at a structure whose history predates every language, every civilization, every human story ever told. The Milky Way is a 13 billion year epic. In a writing on galaxies, Neil deGrasse Tyson once said, "We are stardust brought to life, then empowered by the universe to figure itself out. And when we trace the Milky Way's history, we see how deeply true that is. We were born from galaxy mergers, from the ashes of ancient stars, from matter torn apart and reassembled millions of times over cosmic epochs. The Milky Way is not just our home, it is the timeline that nourished us. and to understand how the Milky Way has remained stable for 13 billion years, how it has pulled in dozens of other galaxies and held hundreds of billions of stars together, we must enter a realm the human eye cannot see, the realm that makes up 95% of the universe's dark matter and dark energy. Below is your complete, precise, detail-preserving American English translation, rendered in a soft-flowing, emotionally rich, scientifically accurate, sleep-friendly narrative voice, exactly matching your requirements. No cuts, no additions, no reinterpretations, only a faithful, elegant translation. The future collision when the Milky Way and Andromeda dance a cosmic tango. As you lie down in the quiet darkness of your room, let your mind drift far into the distant future, a future 4.5 to 6 billion years from now. A span of time so long that every trace of humanity, every detail of Earth as we know it today, may have vanished or transformed beyond recognition. But the galaxies will still be there. And in that far future, a breathtaking cosmic event awaits the Milky Way, and Andromeda will enter a beautiful collision dance, a cosmic tango that lasts billions of years. We call it a collision, but the truth is gentler than the word suggests. Two giant galaxies, each containing hundreds of billions of stars, will approach one another, the way two glowing clouds drift together on a calm night, passing through each other, wrapping around each other, twirling in a dance so long you could write an entire millennium, and the dance still wouldn't be over. The tango of two giants. Imagine the night sky of the future. A silent night when the observers of that distant age, if any, remain to see it, look up and witness a sight no human eyes have ever seen. A faint smudge which for millions of years was just a hazy streak of Andromeda sitting 2.5 million light-years away begins to grow, to bloom, to widen across the sky. Andromeda will no longer look like a small cloud visible only under dark skies. It will swell and swell until its spiral arms stretch across the heavens like the glowing petals of a colossal cosmic flower. And then one night, sometime within the next 4.5 billion years, the two galaxies will pass through each other for the first time. But what may surprise you is this: very few stars will physically collide. The average distance between stars in a galaxy is so vast that if our sun were a grain of sand, the nearest star would be hundreds of meters away. That immense emptiness means that even when two galaxies plunge through one another, almost none of their stars actually touch. A galaxy collision is more like two enormous flocks of birds passing through each other than two rocks smashing together. But something does truly collide. What really crashes together are stellar orbits thrown into new chaotic paths, clouds of gas compressed into brilliant star-forming bursts, spiral arms stretched, twisted, torn into luminous arcs. Supermassive black holes drawn irresistibly toward each other. Like dancers, the Milky Way and Andromeda will circle one another repeatedly. Every sweep of the dance is a pull, a spin, a moment when their structures bend into soft, glowing curves of starlight. For hundreds of millions of years, the sky of those future observers will become a light show. Bright arcs of stars bending like ribbons, pale, swirling streaks drifting like cosmic smoke. Gas clouds ripped open, flaring with newborn stars. Spiral arms stretched out like rivers of light flowing across the heavens. It is a sight no words can fully capture, the universe reshaping itself before your eyes through a gentle but powerful dance. Milkdromeda. The final union. After about 6 billion years, the cosmic tango ends in a final merging. The two spiral galaxies lose their spiraling shapes. The merger gives birth to a new galaxy, Milkdromeda. A massive reddish elliptical galaxy. The red is not the colour of fire or blood, but the colour of aging light, the glow of old stars after the young blue stars have burned out and disappeared. By then, the sky will no longer show the glittering spiral arms of the youthful Milky Way. Instead, it will be a smooth, gentle ellipse, round and soft like the universe, taking a long, deep breath after a dance that lasted billions of years. A vision that makes you feel small but peaceful, as if the universe too knows how to grow old and how to rest. The universe does not end there. Thinking about the Milky Way's future may bring a quiet sadness. Even the galaxy that gave us life will not exist forever in its present form. But this is not something to fear. It is simply part of the cosmic story, a story so vast that every galaxy undergoes great transformations like this. The Milky Way is just one chapter in a novel with no final page. When we look at the night sky, we're gazing at a page of the book we haven't turned to yet, a page that tells of merging, reshaping, and the birth of a new galaxy. Carl Sagan once wrote, "We are a way for the universe to know itself, and when we imagine the future of our galaxy, we are reading the universe's autobiography, a book in which we are tiny lines of text. Drift gently into sleep. Close your eyes and imagine one day unimaginably far from now, the sky will look nothing like the sky you know. Instead of the thin silk-like arc of the Milky Way, you'll see the strange swirling patterns of Andromeda, wrapping around us as two ribbons of light fold into one another, and slowly, all motion settles. The universe breathes deeply. The two galaxies become one, a single, reddish ellipse, old quiet, yet beautiful in the way only time can create. This is the beauty of cosmic impermanence. Nothing stays still yet, everything has rhythm structure and its own gentle grace. And if that merger is the Milky Way's distant future, our present holds something even more extraordinary, the meaning of living inside a galaxy that is alive, evolving, and carrying within it countless stories yet to be told. And to understand the deepest part of that story, we must return to an ancient question. Just how small are we in a universe so infinitely large? Local group, the Virgo cluster, and why our position is good for life. When we look up at the night sky, it's easy to imagine that every place in the universe is just like the quiet little corner. We live in a suburban region of the galaxy where the stars are spaced far enough apart for the sky to feel gentle, where high-energy radiation is not overwhelming, and where the sun can shine steadily for billions of years without disturbance. But when you widen your view, you begin to see that our position in the cosmos is not just coincidence. It is almost an ecological stroke of luck, a gift the universe gives to life. Local group, our small, peaceful neighborhood. The Milky Way does not live alone. It belongs to a quiet collection of about 50 galaxies in a calm corner of space called the local group. Compared to the enormous structures of the universe, the local group is truly tiny. It contains only 3 large galaxies, the Milky Way, Andromeda, Triangulum, M33. Everything else is a forest of faint dwarf galaxies, orbiting the big ones like tiny sparks following larger flames drifting through the dark. If the universe were a grand metropolis, the local group would be like a quiet suburb on its outskirts, a place where you hear the wind more than traffic, and where the night is dark enough for stars to shimmer softly like scattered glitter. The Virgo cluster, the complete opposite. Now imagine somewhere very different, the Virgo cluster, a region of space utterly unlike our local group. The Virgo cluster contains thousands to 2,000 galaxies packed tightly into just a few million light-years. It is a bustling, cosmic megacity where galaxies collide constantly. Gas is ripped out and shredded. Intense radiation floods the environment. Supermassive black holes launch plasma jets tens of thousands of light-years long. It is not a place where a quiet, stable planet could nurture life. It is a cosmic pressure cooker. In dense clusters like Virgo galaxies, barrel past one another at 1,000 km ms, stripping away their gas, the fuel needed to form new stars. Without gas, a galaxy slowly dies, turning into an old reddish elliptical object with no young stars left. If the Milky Way lived inside Virgo, it might have been stripped of its gas within a few 100 million years, and the Sun, as we know it, may never have formed at all. Why is our position good for life? Imagine life as a fragile seedling. A seed that needs 3 things: light gentle and not too harsh. A stable environment free from violent storms. Vast amounts of time to evolve. The universe rarely offers all 3 at once, but the little corner we live in does. The Milky Way sits in a region with just low galaxy density, lowering the risk of major distortions and collisions, low radiation, avoiding frequent blasts of X-rays and gamma rays, slow relative motion, allowing the Sun and its planets to remain stable. No cluster-level stripping, so the galaxy retains gas to form new stars. That is why Carl Sagan once said, "The cosmos is also within us." We are made of star stuff. But that star stuff can only assemble into life if the cosmic environment is gentle enough. The local group and the Milky Way's position inside it is exactly that kind of gentle environment. If we lived inside Virgo, imagine a different scenario. If instead of the local group, the Milky Way lived inside the Virgo cluster, the night sky would blaze with dozens of enormous galaxies dominating the view. Plasma jets from the supermassive black hole in M87 might occasionally sweep across the region where Earth resides. Supernova rates hundreds of times higher could sterilize any planet attempting to host life. Strong gravitational interactions could destabilize planetary orbits, tearing apart solar systems. Some physicists call such regions too turbulent to live. Just as you cannot grow a peaceful forest in the center of a crowded, polluted city, life struggles to take root in galaxy environments that are too dense, too violent, too stormy. Thus, the fact that the Sun, Earth and life emerged within a small, quiet galaxy group can be seen as one of the golden conditions, the perfect environmental recipe for life. Local group. Small but the ideal home. The local group is like a spacious garden where each galaxy has enough room to grow on its own. No overcrowding, no cosmic hurricanes, no constant galaxy collisions like those in enormous clusters. Earth can circle the Sun quietly for billions of years without interruption. Life can slowly evolve from simple cells into complex organisms. Civilizations can rise, look toward the sky and ask questions about the universe. And eventually, on a small blue planet, tiny beings will realize just how rare and fragile life may be in a universe filled with chaos. If the universe were a house, we'd be living in a quiet room. Perhaps it is this very quietness that allowed life to form. Perhaps it is this safe distance from cosmic turmoil that let the Sun shine steadily for 4.5 billion years. Perhaps this small, humble local group is the reason we exist at all. Our place in the universe is not the center. It is not special in the usual sense, but it is well suited for life, a place warm enough, calm enough, quiet enough for the universe to take its time and write its story through us. And when we realize that cosmic peace itself nurtured our existence, a gentler question begins to unfold. In a universe so vast, what meaning does a tiny human being truly hold? The answer lies in the next chapter where science meets philosophy. Fermi paradox. Why is the universe so full and yet so silent? When you look up at the night sky at the faint, quiet stars hanging in the deep darkness, it's hard not to wonder, is someone out there looking back at us? The universe is so vast that human imagination can barely reach its edges. About 200 sextillion stars, a number our brains cannot truly feel. If even one in Milky planets hosts life, then the cosmos should be overflowing with noisy, thriving worlds. Civilizations that have risen looked into their own skies and wondered about us just as we are wondering about them. And yet, despite all the overwhelming probabilities, despite the ocean of stars, despite the seeming certainty that life must exist somewhere, we have heard nothing. No signal, no greeting, no unmistakable evidence, only the perfect silence of the universe. This is the Fermi paradox, the question physicist Enrico Fermi asked during a lunch conversation in 1950. Where is everybody? Intelligent life might be extremely rare. One of the gentlest yet saddest explanations is this. Perhaps intelligence like ours is incredibly rare. Creating life is already difficult. Keeping life alive for billions of years is harder. Evolving from bacteria to multicellular organisms requires a span of time that borders on the impossible. And evolving from multicellular life into tool-making, society-building, sky-watching intelligence, that is a series of fragile leaps. We may be the product of a rare combination of luck, stability, and improbable events like diamonds that only form under the most unusual conditions. Carl Sagan once said, "The universe is not required to be in perfect harmony with human ambition." The universe does not owe us intelligence everywhere. Perhaps only a few scattered pockets like Earth are peaceful enough to nurture it. 2. Civilizations may self-destruct. Another explanation carries a somber tone. Maybe civilizations do arise, but they never last long. They collapse through war, climate shifts, runaway technology, resource exhaustion, or accidents of their own creation. A civilization must survive a long list of death points: internal conflict, dangerous inventions, environmental collapse, pandemics, asteroid impacts, nearby supernova explosions, or simply evolving too slowly to handle their own power. Perhaps the silence of the universe is the echo of civilizations that failed, like stepping onto an empty stage and sensing the absence of actors who were once there. 3. They are silent, or communicating in ways we don't understand. It's possible that there are hundreds of civilizations out there. Perhaps they have reached a level where their communication no longer resembles radio waves or laser light. Maybe they speak through forms of physics we have not yet discovered. They might exist in forms of matter we cannot detect or operate at energy scales beyond our senses. Or maybe they choose to remain silent like wanderers in a dark forest, who make no sound for fear of predators we do not yet know exist. Arthur C. Clarke famously said, "Any sufficiently advanced technology is indistinguishable from magic. If someone is millions of years ahead of us, we might not recognize their presence even if it is right in front of us. 4. The distances are simply too vast." Another explanation is beautifully simple, almost calming. The universe is too large for us to meet. Even if a civilization is only a few million light years away, their signals, whether light or radio, would take millions of years to reach Earth. They may have gone extinct before their message arrived, or our signals might reach them long after they are gone. We are like two travelers walking in the night, each holding a lantern, but the forest is so wide that the lights never meet. 5. The universe may be full of life, yet we still feel alone. The strange thing is this. The explanations for the Fermi paradox do not make the universe less magical. They make it more profound. The cosmos may be full of green worlds, distant oceans and civilizations that once wrote poetry, built cities, sang songs and dreamed. But distance, time and the fragility of life prevent us from ever hearing them. Or perhaps silence is the nature of the universe, not threatening but meditative. A silence like wind at night, soft, wordless, but stirring something deep within. The moment we realize we might be alone is the moment we understand how precious life on Earth truly is. And standing before the paradox of cosmic silence, we face one final question. A question of both science and philosophy. If we truly are alone, what does that say about humanity's place in a universe 93 billion light-years wide? The answer awaits in the next chapter, where knowledge meets the quiet of the soul. Earth, the jackpot in a very special galaxy. When we look up at the night sky and see the Milky Way stretching across the darkness like a faint ribbon of light, it's easy to forget that among its hundreds of billions of stars lies a tiny world, a pale blue dot where life has taken root, blossomed, and written its own story. In this vast universe, Earth is not just another planet. It is the jackpot in a very special galaxy, a gift of balance that almost no other place possesses. Carl Sagan captured Earth with a phrase that became immortal, the pale blue dot. A simple phrase, yet one that carries every bit of fragility, beauty and hope this planet represents. Earth, a miracle in a harsh cosmic sea. The universe is not a friendly place. It is a realm of radiation collisions, blazing stars, violent supernovae shredded galaxies, icy plasma storms and vast empty regions stretching billions of light-years wide. Amid all that, Earth is a soft exception, a rare, quiet pocket, a point of balance nature spent billions of years crafting. Earth has liquid water, an unusual condition, because the universe is almost always too hot or too cold for water to exist in the form that life needs. Earth has a thick atmosphere that holds warmth, blocks harmful radiation, and keeps essential molecules near the surface. Earth has a magnetic field, an invisible shield deflecting the sun's charged particles which could destroy every living cell in an instant. Earth has a climate that stayed stable for billions of years, long enough for life to evolve from primitive molecules to multicellular beings, to minds capable of looking up at the sky and wondering about themselves. The universe was under no obligation to create a place like this, and yet somehow it did. Among 200 sextillion stars, Earth is different. Think about that number, 200,000 stars. Across trillions of galaxies, most are tiny dwarf galaxies where stable, life-friendly conditions are almost impossible. Even in larger galaxies, life may be threatened by intense radiation. Supernova blasts, gamma ray bursts, or chaotic structures where stars form and die too violently. And yet Earth sits in a quiet region of the Milky Way, the galactic habitable zone where stars are not too crowded, radiation is moderate, and there are no nearby supernova waiting to wipe the slate clean. A gentle suburban neighborhood where the sun can shine peacefully for billions of years, nurturing every form of life on this small blue world. It is luck, but not just luck. It is a rare cosmic opportunity for the universe to attempt something it spent 13 billion years preparing for life, that can think, feel love, and question its own existence. Our responsibility not out of fear, but out of love. When people talk about protecting Earth, the reasons are often framed in warnings. Melting ice, rising seas, collapsing ecosystems. These concerns are real and they matter, but maybe they're not the most beautiful reasons to act. We should not protect Earth only out of fear. We should protect it because it is a miracle, a soft exception in the silent ocean of the universe. No other nearby planet offers what Earth gives. The blue of the ocean, the whisper of wind through trees, the smell of soil after rain, the sound of waves against shore, the gentle glow of sunlight as it touches the horizon at dusk. These are experiences that trillions of planets out there may never have. Carl Sagan once wrote a sentence that quiets the heart. There is nowhere else, at least in the near future, to which our species could migrate. There is no second Earth waiting for us. No other world as safe, warm and tender as this one. Earth is home, and when you love your home, you care for it out of love, not fear. Earth, us, the universe. There is something strange, yet profoundly beautiful. The more we search for life in the universe, the more we realize how precious life on Earth truly is. The more we understand the size of the Milky Way, the scale of the universe, the depth of time, the more we feel our existence as fragile yet priceless. We are small, but not insignificant. Across 93 billion light-years in a sea of stars among billions of galaxies, this pale blue dot still holds every story, every memory, every dream, and every hope humanity has ever known. Earth is not just where we live. It is where we love, learn, grow, fail, and rise again. It is the place the universe chose, or perhaps accidentally created, to allow life to understand the universe itself. And when we grasp the fragility and value of Earth, we arrive at the final chapter of this journey, the chapter where science meets philosophy, where humanity's biggest questions soften into something gentle, like a breath in the dark. A chapter that closes the journey through the universe and brings us back to ourselves. Dark matter, dark energy, and the invisible skeletons of the cosmos. When you look up at the night sky, you see bright stars, the silvery clouds of the Milky Way, the faint dark patches where dust blocks distant starlight. But here is the strange truth. Everything you see, stars, nebulae, galaxies, makes up only 5% of the universe. The remaining 95% is made of things we cannot see, things that do not shine, do not reflect, and do not interact with light in any familiar way. Components that are invisible yet govern every motion, every structure, every possible future of the cosmos. They are dark matter and dark energy. If the universe were a long poem, dark matter would be the quiet rhythm that keeps the verse from falling apart, and dark energy would be the invisible breath that pushes the poem endlessly forward. Dark matter, the skeleton of galaxies. When astronomers observed galaxies spinning, they discovered something impossible to explain with normal physics. Stars rotate around the galactic center far too fast. So fast that if their motion depended only on the gravity of stars and gas, the galaxy should tear itself apart like a delicate petal, ripped away by a powerful gust of wind. But the galaxy does not fly apart. It remains intact, a gentle spiral swirling for billions of years. To explain this, we must imagine an invisible presence wrapping around the galaxy, a dark skeleton holding everything together. That is dark matter, which makes up about 85% of all matter in the universe. Dark matter does not emit light, does not absorb light, does not radiate heat. It only pulls a gravitational grip strong enough to bind stars in their orbits. Galaxies into groups, galaxy clusters into superclusters, superclusters into the cosmic web. Without dark matter, the Milky Way would dissolve into glowing dust. Without dark matter, the cosmic web would never have formed. It is the thing we do not see but still feel in the motion of every galaxy, like wind invisible, yet always present. Dark energy, the force that makes the universe expand forever. If dark matter holds the universe together, dark energy does the opposite. Dark energy pushes the universe outward, accelerating the expansion of space itself, a mystery so profound that physicists call it the greatest unsolved problem in modern cosmology. For the past 5 billion years, the universe has not only expanded, it has expanded faster and faster. Imagine blowing up a balloon, and every minute the balloon inflates faster than the minute before, not because you're blowing harder, but because the balloon itself wants to grow. That is our universe, a space that stretches a fabric that multiplies an invisible field that expands on its own. This force dark energy makes up 68% of the universe, the far future, when the universe grows quiet again. Now imagine yourself in a distant future tens of billions of years from today. By then, the Milky Way and Andromeda will have merged into a massive elliptical galaxy called Milkdromeda. Most young stars will have burned out, leaving only the soft red glow of old stars scattered across the sky. And then something strange will happen. Because dark energy continues to stretch space, every galaxy outside the local group will drift away faster and faster, eventually faster than light itself, so their light will never reach us again. One day, the night sky will look the way it did to ancient humans who believed our galaxy is the entire universe. In that distant future, no galaxies will be visible beyond Milkdromeda, no cosmic web, no 93 billion light-year universe. Everything outside our local region will slip beyond the cosmic horizon, not because it's gone, but because the universe is expanding faster than light can travel. Future observers, if any survive, will look at the sky and conclude, our galaxy is the whole universe. Just like ancient humans once did, a cycle of understanding, a gentle cosmic joke, the meaning of the sun in the darkness. Dark matter and dark energy teach us something quietly profound. Most of the universe is darkness. And that is not frightening, because it is within that darkness that light becomes meaningful. It is within that silence that life has room to bloom. It is within that vast emptiness that Earth becomes precious, a tiny blue jewel floating in an endless black sea. Carl Sagan once wrote, "Somewhere something incredible is waiting to be known. A small lantern glowing in the midst of the invisible 95%. And when we understand that most of the universe is unseen, a web of forces, emptiness, and silent expansion, we return to the final, gentlest question: what is the meaning of humanity as we drift through this darkness? The answer lies in the last chapter where science meets the human heart. The open questions, what we still don't know. As this long journey comes to its final steps, we pause before a very special quiet place in the universe, the realm of unanswered questions. A place where science offers no conclusions, only a gentle smile, a listening ear, and a promise to keep searching. For thousands of years, humans have looked up at the sky with the same feeling: the universe is larger than anything we know, and perhaps larger than anything we can imagine. But the most beautiful part is not in the answers we found, it lies in the things we still don't know. 1. Dark matter. The shadow, holding the universe together. We know dark matter exists. We see its gravitational pull. We know it keeps galaxies spinning too fast without falling apart. We know it shapes the invisible skeleton of the cosmic web. But that's all. We don't know what it is. We don't know if it has particles or fields. We don't know how it interacts with the deepest fabric of space. Maybe dark matter is a particle no one has ever seen. Maybe it's the shadow of another dimension. Or maybe, as Einstein once hinted, the most incomprehensible thing about the universe is that it is comprehensible. The part we don't understand, dark matter, may confuse us for a very long time. 2. Dark energy. The force driving the ever-expanding cosmos. Dark energy is the greatest mystery in modern physics. It makes up 68% of the universe, yet we have no idea what it is. We know only one thing. The universe is expanding faster and faster, as if space itself wants to open endlessly, breaking past every boundary. Why is this happening? We don't know. Is dark energy a natural property of space? A new kind of cosmic field? Or a sign of a higher dimensional universe stretching the one we inhabit no one knows? This shouldn't frighten us. It simply reminds us that the universe is full of secrets and that the journey of science has only just begun. 3. Is the universe finite or infinite? We can only observe the observable universe, a giant sphere about 93 billion light-years wide. But beyond that boundary, what lies waiting? No one knows. Is the universe finite, curved like a massive cosmic balloon folding onto itself? Or is it infinite, stretching endlessly in every direction like an ocean with no shore? This question is not only scientific, it is philosophical. It touches the core of existence. Close your eyes and imagine an expanse that never ends, or a cosmic circle where every step forward brings you back to where you began. Both are beautiful. Both make us humble. 4. Does the multiverse exist? One of the boldest ideas in modern physics suggests our universe may be just one among countless others. In string theory and inflation theory and quantum mechanics, the multiverse is not an outlandish idea. But it remains a hypothesis, no direct evidence yet. Imagine, beside our universe there could be others where physical constants are different, where light behaves differently, where matter forms in unfamiliar ways. where life could bloom in ways we cannot picture. If this is true, then we live inside a bubble of reality, one bubble among many. The idea is humbling, beautiful, and strangely heart-opening. 5. Are we truly alone? This is the question that echoes in the mind of every thinking civilization. Somewhere in the darkness between the stars is life whispering. A world with a deep ocean. A city built from light. A civilization that outgrew its own technology. A mind looking up at its sky wondering about us the way we wonder about them. The Fermi paradox says, the universe is so vast that life must be out there. But the silence seems to say, perhaps we're walking alone through a forest at night. This question remains open, and perhaps it will always remain open. Science. A journey with no finish line. The most beautiful part is not the destination but the path itself. The universe is not a finished book. It is a journal still being written, hour by hour, day by day, century after century. Science for sleep is not only science. It is the feeling of lying back and letting your mind rise above the clouds, drift through nebulae, glide between stars, and realize that humanity's search is infinite. Carl Sagan once wrote, "Somewhere, something incredible is waiting to be known." Perhaps it is this, waiting, this openness of unanswered questions that makes the scientific journey feel sacred. And when we stand before these open questions with a heart that knows how to listen, we realize that what matters is not the answers but the human ability to ask. So in the final chapter, we will close this journey with a gentle reflection. In all this vastness, what meaning does humanity hold? And why are we the way the universe becomes aware of itself? The paradox of scale, both vast and tiny. There is something fascinating that happens when we begin a journey into the universe. The farther we go, the more we realize that everything in the cosmos has two faces. At times, things are immense. At other times, they are unbelievably small, all depending on the frame through which we choose to look. And the Milky Way, the galaxy we live in, is the perfect example of this paradox. If you look at the Milky Way from a familiar human perspective, it truly is a large galaxy. A spiral disk about 100,000 light-years across, containing 100 and 400 billion stars, larger than about 95% of all galaxies in existence. Compared to countless dwarf galaxies that hold only a few million or a few billion stars, the Milky Way seems like a gentle giant, powerful and radiant. But when we widen the frame and place the Milky Way beside the largest structures in the universe, massive ellipticals like IC 1101 galaxy clusters, like Virgo cosmic walls such as the Sloan Great Wall, or even the entire observable universe stretching 93 billion light-years, our galaxy suddenly becomes so small it nearly dissolves into nothingness. It's like seeing a very tall person stand out in a small crowd. But when that same person stands next to a skyscraper, they immediately become a tiny, insignificant dot. Not because they changed, only because the frame of comparison changed. The Milky Way, a giant in a small neighborhood. If you place the Milky Way inside a random sample of 1,000 galaxies, as many as 950 of them would be smaller. It's a gentle but striking statistic. The Milky Way is in the top 5% of the largest, brightest, most star-rich galaxies in the universe. In the local group, the Milky Way is one of two big siblings along with Andromeda. The dwarf galaxies around them, the Large Magellanic Cloud, the Small Magellanic Cloud, the Sagittarius Dwarf, all orbit these two giants like leaves swirling around two ancient trees. From this viewpoint, the Milky Way is the giant, a continent among small islands, a vast country surrounded by tiny microstates on the cosmic map. But on the scale of the universe, the Milky Way is just a speck. When we widen the frame further, the Milky Way begins to lose its grandeur. Place it next to the elliptical galaxy IC 1101, over 4 million light-years wide. The Virgo cluster, home to 2,000 galaxies. The Laniakea supercluster, spanning 520 million light-years. The CFA2 Great Wall, stretching 500 million light-years. And the Milky Way becomes a glowing grain of dust drifting in the wind. And compared to the observable universe 93 billion light-years across our galaxy, vanishes completely from ordinary imagination. The Milky Way, once in the top 5% of all galaxies, becomes nothing more than a quiet spark lost among trillions of others. At that moment, we understand that everything in the universe has a relative place. Nothing is truly large. Nothing is truly small. Everything depends on the frame. The paradox of scale. Both sides are true, and the miracle is this. Both perspectives are completely right. The Milky Way is enormous compared to most of its neighbours. The Milky Way is tiny compared to the universe itself, just like human beings. One person can be someone's entire world, yet when standing before the sea, the mountains or cosmic time, that same person becomes a fragile speck of existence. Change the perspective and everything changes. Understanding this is the key to stepping into a larger world, a world where we know when to be humble, when to be proud, and when to slow down and listen to the rhythm of our own breath. From the perspective of time, even the Milky Way is just a moment. If space can shrink, the Milky Way time can too. Our galaxy will not exist forever. It was born from faint mini-halos after the Big Bang. It grew through mergers. It is moving toward Andromeda and will form Milkdromeda in 4-6 billion years. And far beyond that, it will age, fade, and dissolve into the eternal darkness of an expanding universe. On cosmic time scales, the Milky Way is just a chapter, not the whole book. And we, small beings living on a blue planet in the Orion Spur, are just a single line of poetry within that chapter. A beautiful line, but still just a line. The journey of perception, learning to choose the right frame to understand the paradox of scale, is to understand that the universe always asks us to shift perspectives, a lesson science has taught us many times. Earth is not the center of the universe. The Sun is just an ordinary star among hundreds of billions. The Milky Way is not the entire cosmos. The observable universe is not the whole universe. Each time we widen the frame, we come closer to how the universe truly works, and each time we grow more humble, yet more filled with wonder. Einstein once said, "A sense of wonder is the source of all true science. Wonder-awe is the root of discovery." The paradox of scale does not make the Milky Way smaller or larger. It simply reveals a truth: everything can hold the beauty of both greatness and fragility. And when we accept this, that the Milky Way is both vast and tiny, that humanity is both fragile and meaningful, we are ready to enter the final chapter of this journey, the chapter where we listen to the universe's last, most delicate question for us, our home in the sea of stars and a good night wish. After a very long journey from the nearest stars to the farthest cosmic walls, we gently pull the lens back in. All the cosmic maps slowly contract, all the colossal structures fade like pale mist, until what remains before us is just a faint river of light stretched across the night sky. A soft streak of milk, a silver road curving toward the horizon. That is the Milky Way, the only home humanity has ever known. We've travelled so far only to return to this familiar place again, just as T.S. Eliot once wrote, "We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time." After all the mind-bending measurements and distances that stretch beyond intuition, we return to that delicate ribbon of light across the sky. But this time we see it with different eyes. The Milky Way, grander than we thought, yet smaller than we imagined. Throughout this journey we discovered that the Milky Way is not some forgotten island in a sea of stars. It is a galaxy in the top 5% of the universe's largest, a magnificent spiral, filled with hundreds of billions of stars, rich in gas, rich in energy, rich in history. If galaxies were nations, the Milky Way would be an empire radiant, powerful, alive. But at the same time, we also saw that when we zoom out far enough, the Milky Way becomes just a modest speck within the 93 billion light-year span of the observable universe. One star among 2 trillion galaxies, a tiny swirl in the vast network of the cosmic web. A quiet traveller drifting among the deep gravitational currents of Laniakea. It is large, and it is small. Both are true because the universe never tried to choose a scale that fits human intuition, and on a tiny planet inside that galaxy, there is us. When we zoom in one last time past the spiral arms through the Orion Spur, beyond the sun drifting through thin clouds of dust, we stop at a small blue dot resting in a soft pocket of darkness. Earth. A grain of dust, but a grain of dust that feels. A grain of dust that loves. A grain of dust that observes the entire universe and dares to ask about its own existence. And on that planet there is you, someone lying down, perhaps after a long day listening to this story, now letting your heart soften, letting sleep draw near. Out of all the countless places in the universe, you are here in this moment. That is a delicate coincidence, an incredibly rare gift. Carl Sagan once called Earth the pale blue dot, and he said it underscores our responsibility to deal more kindly with one another, and to preserve and cherish the only home we've ever known. The vast universe does not make us meaningless. It simply reminds us of the fragility of reality and the beauty of the place where our lives unfold. Smallness does not make us weak, it makes us gentle. Seeing the true scale of the Milky Way and our place within it does not make us more anxious, it makes us lighter. Because we understand that all the worries, irritations and burdens we carry each day are just tiny ripples on the lake of time. They come and they go. The universe does not demand that we be strong all the time. It simply reminds us you don't need to strain to become someone else. You only need to be yourself, a small being who knows how to love, how to think, how to dream of the stars. Smallness does not make us insignificant. It allows us to pause, take a deep breath and realize we don't need to race against the entire universe. You are allowed to rest. You are allowed to soften. You are allowed to close your eyes and let everything drift away like faint glowing nebulae. A lullaby, close your eyes and feel yourself drifting inside the galaxy. Now, if you'd like, gently close your eyes. Imagine you are lying on a tiny blue speck light as a petal, slowly spinning inside a vast galaxy. The Milky Way drifts quietly across the night like an endless silver river. All sounds fade away, all thoughts settle. You are being held by the universe, by its silence, by its immensity, by the tenderness it offers to everything that is alive. Let your heartbeat fall into rhythm with the slow rotation of the Milky Way. Let your eyelids grow heavy like drops of dew resting on a leaf after a long night. And let sleep come to you like the soft glow of distant stars. You are not alone. You have never been alone, because you are a part of this galaxy, and this galaxy is a part of you. Wishing you a good night beneath the stars. Sleep deeply, peacefully, as gently as light drifting across the sky. You already have your own place in the Milky Way. And now, as our journey across the grand staircases of the universe comes to a close, we return to a gentle truth. The Milky Way, our 100,000 light-year-wide spiral home, is only a speck of dust inside the 93 billion light-year observable universe. Yet on that speck lies Earth, and on Earth there is you, a small being who knows how to look up at the sky and ask questions about your own existence. Science doesn't distance us from the world. Science helps us see more clearly the fragile beauty we are living within light that spent tens of thousands of years crossing our galaxy, and yet you can feel it with a single glance at the night sky. Let that thought rest over your mind like a soft blanket. Let everything loosen. Let your worries fade gently into the dark horizon. You're lying on a tiny grain of dust that knows how to wonder about the universe, and that alone is a kind of miracle. Wishing you a peaceful night beneath the stars of your very own Milky Way.